All right, so next up in Unit 5, this whole unit has been about triangles so far. So we talked first about classifying triangles, then we talked about if I already have two triangles that are congruent, then I can label corresponding parts. So now we're going to get into how can I determine if two triangles are congruent. And so one way we talked about was there were a couple key parts we talked about in the last video, having a reflexive side, having vertical angles, having a midpoint or having an angle bisector. Each of those are features that can help us to determine if two things can be congruent eventually, but how to actually determine if they're congruent, we're going to have 5 triangle congruency tests in order for us to determine if two triangles can be congruent. So the first one we'll talk about is side, side, side. Okay, so as you'll see with each one of these that we talk about, each one of these tests is going to talk about a combination of side lengths and angle measures in triangles in order for these two triangles to be considered congruent. So let's look at this first one. So side, side, side. So my definition says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay, so what this basically means is that if I've got two triangles, I've got my two triangles here, triangles A, B, C, and triangles D, E, F, and I know that in these two triangles, I've got two sides that are both equal, one in each one, and then another two, and then another two. So basically, the 3 sides in this triangle are congruent to the 3 sides in this triangle. Well, if I have a case where I have two triangles that all 3 sides are congruent to the 3 sides of another triangle, then that means that those triangles have got to be congruent. That means that their angles have automatically got to be the same as well. So I don't necessarily have to even know the angles. If I've got side, side, side congruency, then that's good enough for me. I don't have to know anything else. Okay, so let's keep talking about this. Okay, next one is side, angle, side. So with side, angle, side, if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then these two triangles will be congruent. Okay, so in this case, I've got two sides that are going to be congruent. Okay, so here my sides are AB and DE. I mark them both with one tick mark to show they're congruent. And then AC and DF, I mark them with two tick marks. Now again, these tick marks don't necessarily tell me how long these sides are. It's not necessarily that this is 1 and this is 2. Just saying that whatever these side lengths are, this one is congruent to this one, and this one is congruent to this one. So if I've got two sides and then the angle, or what's known as the included angle, so that's going to be the angle that's created by these two sides. Okay, so if you see right here, side BA and side AC, they create angle BAC. So angle BAC is the included angle between these two sides. So if I've got the included angle for this triangle and included angle for this triangle, and they're congruent along with these two sides, then these two triangles are going to have side angle side triangle congruency. Okay, now it's very important to make sure you do get the order correctly, because there are other ones that we may see that have similar features. Like there are other tests that will have a case of maybe two angles and one side having to be congruent, but depending on the order in which they're presented could determine on which congruency test we use to prove. Okay, but for this one, this is the only one that uses two sides and one angle that will work. Okay, let's keep talking. Next one, angle, side, angle. So let's open this one up. So angle, side, angle. If two angles and the included side of one triangle are congruent to two angles in the included side of another, then these two triangles are congruent. Okay, so angle, side, angle is kind of the flip of side, angle, side. So with angle, side, angle means we've got two sets of congruent angles, angles B and E and angles A and D, and then the side that is in between these two angles. Okay, so in this case, side AB is in between angles B and A, side DE is in between angles E and D. So if I got a case of where I've got two angles and the included side are congruent to two angles the included side of another one, then these two triangles will have angle, side, angle congruency. All right, so next up, let's talk about angle, angle, side. So as you notice, with angle, side, angle, and with angle, angle, side, the parts that they use are similar. Okay, so in both of these, I've got two angles and one side that are going to help me to determine congruency. But depending on the order, that's going to determine what type of congruency we have. So let's look at angle, angle, side. Okay, so if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Okay, so this time we've still got two angles. Okay, so I got angles A and B and angles D and E. Okay, so these are corresponding parts, so that's why they're lined up correctly. That's why they're notated the way that they are. So it says two angles and a non-included side. So remember, with angle, side, angle, it was two angles and an included side, meaning the side that is in between the two angles. But for angle, angle, side congruency, it's going to have to be one of the non-included sides, meaning that really I've got two options here. I can either go with sides A, C, and DF like I already have marked, or if I wanted to, I could have made another option. I could have instead said angle A, angle B, and side BC, and then angle D, angle E, and side EF. Okay, so I could have either picked AC and DF or BC and EF, and it still would have been angle, angle, side congruency because both of those are the non-included sides of the angles that I have chosen. Okay, so whenever you're going through and you're kind of stuck on which one is this, is it angle side angle or is it angle angle side, just go through and name the parts so you have them in order. Okay, so with this one, you'd name it in order exactly how you have it marked. Angle, angle, side. Or even if you did the reverse and you said side, angle, angle, it'd be the same thing going forward or backward. Okay, so just go through and just name the parts you have labeled in the order that they appear as you're going around the shape, and that's going to determine which test you're using, if it's angle side angle or angle angle side. Okay, let's talk about the last one that we can use. Okay, so this next one, hypotenuse leg. So this one is a little bit different. This one is going to be specific only to right triangles. Okay, so here we have, if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then the triangles are going to be congruent. Okay, so in this case, again, has to be a right triangle. So a little vocabulary lesson. So whenever we have a right triangle, we have with the side lengths, we classify them two ways, either their leg or their hypotenuse. If they're a leg, that means they're one of the sides of the triangle that helps to create the right angle. Remember, a right triangle has to have exactly one right angle. So in this triangle, sides BA and AC, they're my legs. In this one, sides ED and DF, they're my legs because they help to create the right angle. So that leaves the other side, that's going to be my hypotenuse. Now, the hypotenuse, you can consider it as your diagonal side, you can consider it as your side that is opposite from your right angle. But that's going to be your hypotenuse. So if you've got two right triangles and they've got one set of legs, so in this case AC and DF, that are congruent, and then they have their hypotenuses, BC and EF are congruent, well then that's enough for us to know that this other leg, this other set of legs must be congruent as well as these other angles that we haven't mentioned either. They're also going to be congruent. Now, the other ones, side, 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 angle, side, angle, side, angle, 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 side, they all took three pieces of information. But this one on the surface, hypotenuse leg, seems to only take two. So where does that third piece come from? Well, keep in mind, with hypotenuse leg, it's got to be a right triangle, meaning that with every single case of hypotenuse leg, there's always got to be a right angle involved. So you could say hypotenuse leg right angle, but that doesn't really roll off the tongue as easily. So that's why we'll just keep it just a hypotenuse leg and then the understood right angle that comes along with it. So we talked about 5 triangle congruency tests that do work. Let's talk about 2 that definitely do not. Okay, so we have 2 that definitely do not. I don't really have pictures for them, but I can kind of talk through them. So one that we have is this one, AAA, which is going to represent angle, angle, angle. So the reason why angle, angle, angle can't work for us. So if you think back to when we talked about equilateral, equiangular triangles, okay, so an equilateral triangle was a triangle in which all the sides were equal. An equiangular triangle was a triangle in which all the angles were equal. Now, with an equiangular triangle, and also keep in mind the triangle sum theorem, we learned that the only options for the angle measures in an equiangular triangle were 60, 60, 60. That was the only options we could have. However, with an equilateral triangle, we could have triangles with sides of any length because equilateral just means all equal sides. So in an equilateral triangle, I could have a triangle that has side lengths of 5, 5, 5, 7, 7, 7, 9, 9, 9, and so on and so forth. And every single equilateral triangle would also be equiangular. So just because a triangle, or just because two triangles have 60, 60, 60 as their angle measures, doesn't necessarily mean that they're going to have equal sides well, because I could have an equilateral slash equal angular triangle with angle measures of 60, 60, 60 and side lengths of 5, 5, 5. But I could also have an equilateral slash equal angular triangle with angles of 60, 60, 60 and sides of 7, 7, 7. So that's why angle, angle, angle isn't a reliable test for us to use. Another one that isn't reliable for us to use is side side angle. And this one is a little bit harder for me to illustrate in the drawing, so I am going to link another video along with your assignments to kind of illustrate a little bit better than I can why why side side angle isn't a reliable test for us to use either. So when in doubt, just keep in mind that these two, angle, 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 and side side angle, are not reliable tests for us to use.